Hello, let's continue our Sudoku adventure with Counter-Argument by Matt Tressel. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box. We are placing the digits 1 to 6 exactly once each. We also have these peach lines in the grid. Sometimes they're a loop, but it doesn't matter. Still considered a line. Any 3 adjacent digits along the line have one of each of a low, medium, and high digit. So let's take these 3, for example. We need one of each of a low, medium, high. Maybe the low is here, a 2. Low is 1, 2, medium is 3, 4, high is 5, 6. We're just sort of dividing it into thirds. So we could do 2, and then we could do 3, and then we could do 6, right? So within these 3 cells on this line, we've got one low, one medium, and one high digit. But keep in mind that it's every 3, and so these 3 also need to have one low, one medium, and one high. So if we take this loop, for example, these 3 have one of each, 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 etc., all the way around. All right, so that's entropic lines. We also have circles in the grid. A digit in a circle indicates the total number of times that digit appears on lines in the grid. So if this was a 3, for example, a 3 in a circle, that means in total, if we look at all the 3s in the grid, exactly 3 of them are on a line. So we might have one here and one up here, and then we don't allow any more 3s on lines. It's like there'd be one here maybe that's not on a line, just as an example. So we'd have exactly 3 on a line. Now the squares are kind of opposite. A digit in a square indicates the total number of times the digit does not appear on lines in the grid. So if this was a 3, let's do 4. If this was a 4, that means that there are 4 4s in this grid that are not on lines. And then there's going to be 2 that are on lines. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, with entropic lines, I always like to start by coloring. Now, what am I coloring here? Well, let's do green, purple, orange. So in this group of 3, and I just kind of randomly picked it on the longest line, in this group of 3, we need one low, one medium, one high. So we know we're going to have one of each. Whatever this one ends up being. If this is a 2, that means green is low. If this is a 4, that means green is medium, right? If this is a 5, that means green is high. We don't know which is which, but we know that this covers all 3 of them. So we can color them and say, well, we don't know which is which, but we do know that they're all distinct. Now, if we continue, these 3 already have a purple and an orange. So the only distinct color left is green. And you'll notice that that starts to cycle. These 3 already have an orange and a green, so they need a purple. And then we're going to end up with an orange, and then we're just going to keep going. Green, purple, orange, green, purple, orange. And notice that does this, in order to be a loop, it has to be a divisible by 3 length, and this is. All right, so that is colored. And what we know with these colors is that there's one of each color. There's 2 of each color in every row, column, and box. So let's think about this box then, because this is completely covered by lines here. In this box, we know that these 2 are going to be the same low, medium, high. They're going to be the same color. So what color do we have left that we can do twice? Well, that's going to be the purple. And so then, but we don't know that this follows the same order as this, right? We can't just immediately say this is green, this is orange and this is green. But we do know this is orange because it sees 2 greens already. It cannot be green. Both greens are used up in the column. And it can't be purple because both purples are used up in the box. So this does have to be orange and this does have to be green. But not because it had to follow the same order as this one. It just happens to. Now in this column, we're missing a purple. So that's purple, meaning, this is going to have one green and one orange on it. And these 2 greens tell us this is orange. That's green, and that leaves the orange here. We knew this was orange already. I was going to say one is green, one is orange. So that uses up both of our greens. So this had to be the orange. But we actually could finish it. This row's got a purple, and so that means that's duplicated here as a purple because of the cyclical nature. This sees 2 greens, so that's orange, and that's green. This column needs another purple. Okay, we're getting some good coloring in here. We need a green and an orange here that we don't know the order of. But we do know this is orange for the row, or if you prefer, because there's a green orange up here. Usually more than one way to determine the same thing. When they agree, that's good. This is, okay, we need 2 greens in this box, and they can't put any more greens over here. There's already 2 greens in the column. So the greens go here. Oh yeah, and that finishes that column. That would be an easier way to say that. Okay, is there anything else we can say here? I don't know that there's more coloring yet. Let's think about these circles then. So whatever goes in the circles, it appears that number of times on lines. We know these are two different digits, and not only that, they're at least two apart from each other. Now, how many, so let's look at green first. How many greens can be on lines? Luckily, we have colored all of our lines already. So if we look, we can have, grouping these is important. Let's only highlight the greens that are on lines. And we can group these as, these are grouped as a box. So this counts as 1. This box counts as 2. So we can have 2 on lines. In fact, we will have 2 on lines at least. In this box, it'll be on a line. So that's at least 3 on lines. And then we could have a 4th one on a line, I think. If we had this on a line, that would be here and here and here. Yeah, that could be 4. So this has to be a 3 or a 4 because there isn't a 5th place to put on a line. And we know that at minimum, we're going to have 3. With this being 3 or 4, that makes it medium. All greens are 3, 4 only. Because, let me explain that. Like that may not be immediately obvious. We have said that this green is going to be a 3 or a 4. Because no matter whether it's a 3 or a 4, that makes green medium. And we were marking, hey, all of the greens are the same low, medium, or high. And because now the only choice is for it to be medium, that makes all of these a 3, 4 pair. Now this purple, we know the purple isn't going to be 6 because we know that, let's see, what do we know about purple? Hold on, let's take a look. Purple could be, let's see, 1, 2, 3, 4, 5. Actually, purple needs to be very high. Sorry, I said the complete opposite of what's true. We need in this box, purple, that's 1. This box will use 1. This box will use 2. This box will use 3. And so in these boxes, there's a little bit of optionality. So there are at least 3 purples are on lines, but we can't use 3 or 4 here. We know purple's not medium. That means it's not low, it's not medium, it must be high. So all purples are high at 5, 6, and all oranges are 1, 2. Now I have colors I'm used to for this once I know what they are. So I'm going to change all of the oranges to blue. I'm going to change all the purples to orange. Then I'm going to change all the greens to purple because that's what I'm used to. All right. Once now that I know what color they are. All right. It just makes it easier for me because that's what I do every time. Now we also have these squares that we need to be careful about. So we know that orange now, that used to be purple, orange is now on 5 or 6 lines. So we know that's 1 guaranteed, 2 guaranteed, 3 guaranteed. I think we have to be here and here. These have to be the same digit as each other. Let me explain. Within this box, if this is a 5, hold on, does this work? No, I'm thinking about this wrong. Well, first of all, if it's a 6, then they might have to, every single one has to be on the line. So these are both 6s. If it's a 5 though, I don't think that forces them to be 5s. Because if it's a 5, then we have 1, 2, we have 4 guaranteed on here. We just need 1 more. So this would be a pair. This would be a 5, 6 pair. Oh, interesting. Okay. So one of these is always 6, no matter what. That does do eliminations. It means that's not 6, and it means these aren't 6. But do we need to use that? Probably not. Let's think a little harder about what's going on here. Can we color any of the, can we subcolor any of these, like the 1, 2s? Or do we, okay. We have 2 digits where these represent the count of how many are not on lines. Interesting. So we know whatever this orange digit is does not also go on a, okay, so the only digit that could go in a circle and in a square is the 3. Let me start with that. Because that would say that 3 are on lines and 3 are off lines, and that adds to 6, and that's perfect. But any other digit cannot be both in circles and in squares. And so whatever this digit is does not repeat in squares. So we know this isn't 5 or 6 at all because of the 5, 6 pair seeing it, but we also know that this digit doesn't go here. So this digit is either the same as this digit or it goes here, but I don't know what to do with that. So if a 3 goes on here, then there's something I'm missing about this, clearly. I don't think there's more I can color. That would certainly be helpful. So do we know whether or not these are orange at all? I think we proved these can't be orange. Is that true? Okay, I will say that because of this box and this box, we always have at least 2 of a digit on a line. So we can't make these orange at all because these are saying that there's 5 or 6 off lines, but we know they're going to be on a line in this box and this box. So these are not orange. These are purple or blue. They're from 1, 2, 3, 4, I guess is one way to put that. Now, is 1 going to be difficult to fulfill? One off means that we'd have 5 ones. 1, 2. It would mean that okay. I don't think that with these can be 1s because this box has a blue off the line. We cannot put a blue on the line in this box. And when we put it in one of these when we put in one of these squares, that also says it's not on the line. And so there's at least 2 off lines. So these can't be 1s. Now, can they be 2s? That would mean that in every other box, the 2 is on a line. So in here and here, here, here. 1, 2, 3, 4. So the only way we're putting a 2 in a square is if they're in these 2 cells. And so if it's in this cell, if 2 is in this cell, then this can't be a 2. Right? If this were a 2, that's saying that we have 2 2s off lines. But we know that this is off a line. It counts itself. And we know that the 2 in this box is off a line. And so the 2 in this box would have to be on a line, but it ends up here, which is off a line. That's 3. So this can't be a 2. And so this ends up being purple, not blue. So that finishes the purples for the row. We need a blue and an orange. What can we say about this then? We have a 3, 4 pair. So the 3, making them both 3 would make sense. Making them both 4 is impossible. So there is a 3 in one of these 2 cells. Do they see anything that they see this cell and this cell, unfortunately. So it eliminates 3 from these cells that we already knew weren't 3. But we know that 3 is represented in at least one of these 2 cells. Now, they could both be 3, I believe, unless there's some subcoloring argument. It may be time to subcolor the 3 4s. So let's just make this yellow, and let's make this red. So we know that this is the yellow, this is the red, this is yellow, this is red, this is yellow. I'd love to prove that this is either yellow or red, but I don't know how. We know this isn't yellow, so if it's a 3, 4, it's red. If this ends up a 3, 4 pair, then we know this must be the 3, because we can't have the 4 be in a circle and a square. So the only way that we avoid that is making this a 2, which would mean that there are, see, there's a 2 on here, there's a 2 on here, there's a 2 on here. Right, it would mean that this is a 2. That's what that means, that we kind of already decided that. In fact, we can do even better. This would be a 2. This would be a 2. We know this would be a 2 because that's what we're starting with. This would be a 2. And so then this would be a 2, making this a 2 and this a 2. 1, 2, 3, 4, 5. So this is where the 2s would end up. I don't think that's a problem. Darn. Do I need to subcolor the 1-2s? We could do yellow, red again. Yellow, red, yellow. Maybe I shouldn't do yellow, red though. Let's just make one of them gray and leave make the other one green. Green and gray. That's gray. That's green. This is gray. Oops, this is gray. This is green. So this is gray. This is green. Green's in one of these two. Ah, interesting. Green's in one of these two. Oh, green is here. Right, where's green go in this box? These greens look in. So this is green. And then that makes this have to be the blue-green one too. This is the only place for green in this box, which makes this an orange 5-6. Okay, and that makes this a purple 3-4. Interesting. 3-4 pair does make this a 2. Okay. Yeah, we know this is gray. Yeah, this has to be the gray too. It's not purple. All right. So all the grays are 2. All the greens are 1. All right. I just needed to figure out the subcoloring is what I had to do. This is an orange 5-6. This is a purple 3-4, and it's actually the red version. And then this is a blue 2, which is green as well. I think there's a little bit too much color going on here. Let's get rid of the subcoloring for, we can just do this. Get rid of the subcoloring for blue. Oh, we have digits for them, and they're all done. So how are we resolving the rest of this? So this circle here, maybe I have to subcolor the 5-6s as well. I guess we could just use gray and green again. So gray, green, gray, green, gray, green, gray, green, gray, green, green, oops. Gray, sorry, green and gray. So they're fully subcolored. So we know that gray is actually on, let's see, 1, 2, 3, 4, 5. Gray is on 5. Like gray is off of this line. So gray has to be the 5 because it's in a circle, and that makes the green our 6. Okay, so subcoloring was key to this puzzle. All right, and then we know yellow is on 4. If yellow is on 4, then it has to be the 4. And that makes green or red the 3, which makes this have to be the, hold on, red is on 1, 2, 3. Okay, so that makes that a 3 and that a 4. And we're done. Okay, perfect. Yeah, we knew we couldn't have a 4 in the circle and the square. All right, let's get rid of the subcolor stuff here. All right. Yeah, subcoloring. Okay, that was necessary. I was resisting it for a while just because it's a huge clutter, but yeah, it was needed. Really interesting puzzle, Matt. Sorry it took me that long to think to subcolor, but there we go. Let me know how you did. If you enjoyed this one, don't leave a like, subscribe, and a kind comment below.